Okay, it's starting now.
Okay. Good afternoon, ladies and gentlemen. I'm doing a small presentation about the methodology we have behind the museum process implementation. It fits very well into the theme of this year's CIDOC, because we have to do with digitization. We are in the digital areas, and I think we heard yesterday already that digitization already affects processes, not only data, but only the work, the way we are doing our work. We are doing different businesses together. And I'm the chair of this group. It was started 10 years ago. When I proposed this working group 10 years ago, I didn't expect it takes probably 10 years until this is becoming popular. And now, after 10 years, I see it's probably already 15 years too early. But I'm quite hopeful that this museum, this business management will become popular in the near future. It's very popular in industries. It's very popular in healthcare. I'm already involved in a healthcare project where we call it clinical pathway. So it's a way how medical doctors are doing surgeries. It helps, it improves the quality of surgeries and so on. And similar things we want to do now in the business area, in the museum area. And I have a short agenda for today. I will try to introduce you and explain some basic terms. Then I will look into the museum domain. What are specific issues and requirements? Are there any standards and frameworks? And then I will explain a use case that is related to the spectrum. As I think you all know the spectrum. I would call it standard by Collection Trust for many 20, 30 years already available. And here we have a main procedure. It's called object entry. And this is part of a use case. I would call it an acquisition process. I have put here group work. This presentation I did already 4 years ago. I had 30 or 40 participants in Milan, and this was a group work face-to-face. So today we have no group work, probably on another occasion. We can have a dialogue presentation, but not today. And then I will go more in technical details, how we can implement such a use case using computerized systems. I present you now a lot of definitions. One definition is what is a procedure? And we have in the terminology the term SOP, Standard Operating Procedure. And you have already here a link to Wikipedia, and you find a lot of scientific literature on this. So I repeat here what is written. A standard operating procedure, SOP, is a set of step-by-step instructions created by a business to help workers carry out routine operations. So that is very important definition. So it should help workers in common sense, curators, managers, and everybody else involved in the operation of a company or an organization. We have here terms step by step. For example, if you know programming, meaningless word language, you have to learn to formulate your problem step by step, because we have in the computer a sequential operation of instructions. So if you're an informatic person, you know it's based on the von Neumann principle that dates back 70 years already. And the purpose doing this is to achieve efficiency. So if you have probably 5 curators and every curator is using a different procedure and different way to document an object, for example, then you might have a problem, harmonize this. And you should have standards how to do it. That's where spectrum comes in. These are guidelines, more or less. And the purpose is to have a quality output and uniformity of performance. And we should reduce miscommunication and failure to comply to industry regulations. So compliance is a very popular word. That means you have to be in line with standard operations, for example. So if you're a medical doctor, if you're doing a surgery, then you have to comply with they call it golden standard in this field. You cannot do what you want with a human being. You have to follow some principle. So compliance is a very important thing. And I bring you a small example to demonstrate this. We have different standards, regulations, proposals in different frameworks. For example, CIDOC has developed many years ago some fact sheets, and object entry is described, it's only an outline. Object entry is described as registration, step by step again, when an object enters the museums. And you can number these steps, you can define these steps. And if you look, for example, in the latest version of, I think you can see it, of Spectrum 5, then you have here guidelines for object entries. And you have here, it's not called step, but you have here the blue lines set as steps. And the rest of the text is a description of steps. And here you have, for example, the object is brought into the museum. So it's done by a depositor. So what we don't have here, for example, and we come later on to this, we have an organizational structure, we have roles. For example, here you have the registration probably, you have a registrar. So these are the roles and these are the organizations. And that is a very important thing if we are speaking about business process. So the next step will be the object is entered into a register, managed by a registrar. So you have probably alternatives. You can have can get an object because of a lending procedure. If you need an object from another museum for exhibition, or can acquire it, then you have to do an inventarization. You have to make it as part of the museum's property. Then you have another step, the object data are now recorded and so on. So here you have a stepwise formulation of this process. A business process is identified by we want to achieve a specific target, a specific service. We want to set up a service and we need a process to support the service. Or we need a service to make a product. For example, a product could be an object ready for exhibition. And then we have some steps to document this product, to do something with this. So the service or the product has to serve a particular goal. So with an object documentation, the goal is to have this object in an exhibition, for example. And the next step is we have this verbal specification had in the previous overhead. We are going to visualize this. And if you have some experience in programming, you probably know this very old term flowchart. So a flowchart, which is already standardized by the ISO organization, the flowchart describes in a visual way how a program is acting. So we have sequences of activities and we have decision points where a sequence can be interrupted. And then we have already rules in this process. If you look below here, you have a process, the next process, so you have a decision point here, do something else, a next decision point, and finally we stop here. And we'll come to this more in detail later. If you look to the object entry, and if I speak about Spectrum, I like to refer to Spectrum version 3. At the moment we have version 5, but in a project many years ago, I analyzed the Spectrum 3, and this is it's still an excellent work, this basis. And we not only have the processes, we have also the data connected with the process. For example, if you're registering the project, an object, so you need some data. You need the depositor, you need the title of the project, of the object, and something else. So in the Spectrum procedure, as I have shown you some minutes before, you have step 3, and these steps are not longer used in Spectrum, but to structure this whole work better, I'm still using steps, the term step. Step 3 is prepares the arrival of an object. Step 4, we make record of the object. Step 5, checks the condition and make a record. For example, if the object is not a good condition, you must do something or refuse to use this object. The next is give a copy of the record information to a depositor. So if somebody is offering, sorry, I have to give entrance for 2 people. Yes, so we have to make a record of this information, send it to the depositor. Okay, and I commented here, we are following Spectrum 3, but this is quite close to the actual version. Now here you see a visualization of a process. And you see some rectangles, receive and manage an information from a depositor. So this rectangle represents a step, and the arrow means the sequence of steps. So the next step, you have the activity, we could call a step an activity, make a record. And in computerized times, we are using screens, and we call these masks. And I have made 10 years ago already a whole set of masks already supporting the Spectrum standard. And this is the first mask, the M01. We'll see it later, consists of data fields. And here we have the possibility to collect all the data for recording an object. And then this is a part of the delivery of an object to a museum. So we have the interaction between a depositor and between the museum. And you have here dotted lines. The dotted line here comes to the computer, refers to the computer system. So we have the line here where you have the symbols, the icon of people. These are the human tasks here. So that's a task which are performed by a human being. And below you see here the icon of a computer, of an old-fashioned PC, probably not used anymore, but that was the time when that's still the symbol. And now we have that as a computer programs, tasks in a computer system. So we have S02, execute data entry mask, M01, and update database. That means a computer program is now running, which presents a data entry screen as an app, as a screen on a PC or something, where you can enter data, and these data are stored in a database. And after this is done, the control, the program reports back to the human being. I have recorded this, and you can go on. Then the next thing is we are generating a receipt to the depositor. So the depositor gets a written or a paper with a with an acceptance message. So the museum is accepting this object, and then we have it in a written way. And to generate this repeat, you have also here a computer program that executes a report. That means that produces a report. And you see here, sorry, the label S0, S01, and sorry, and S03, 02 and S03. That is an abbreviation of service. Probably we know since, sorry, since 10 or 15 years, we are speaking about web services. And if you start making a computer system, you need to decide for an architecture, and then you can decide for a service-oriented architecture. So this, this overhead, this slide refers already to this state of the art, even it's 15 years old, design principles of computer system. And M, you see, with M you can abbreviate user interfaces, screens. This can be supported by sound, by video cameras, anything else. And R means report. So we have three artifacts in a computer system. We have the user interface controlled by masks. We have the operations in the computer systems, abbreviated by S. And then we have printed communication in printed form called reports. Nowadays would be a PDF, for example. And I have already made a link to the verbal description. So if we go back, here you have step 4, we make a record of the object, and step 7, send a copy of the receipt or give a copy of a record information to the depositor. And if you look now in this visualization, here we have step 4, and here we have steps 6 and 7. And then you can go back to the spectrum standard or to the CIDOC fact sheet or something else. And then you can see, is this in line with a standard procedure? I hope this becomes a little bit clear. And I come to the next definition. It comes, it dates already back 30 years. 30 years ago, the Workflow Management Coalition has been the first organization dealing with that. And since 20 years, we are speaking about business process management. And you have here a link to Wikipedia describing this. And the business process management is now a task of an international organization. It's called Object Management Group. And the Object Management Group is defining standards. These are OASIS standards in this domain, in this business process domain. And as a definition, we have BPM is a discipline involving any combination of modeling, automation, execution, control, measurement, and optimization of business activities flows. That means we have a lot of activities here. We are measuring things, we are controlling things, we are modeling something. Everything belongs to the domain of BPM. And then the goal, then it should support enterprise goals. It should connect systems, spanning systems, employees, customers, and partners. So it's quite a sophisticated definition. You have here a small figure. You have input to a system, you have people, you have processes, and then you have here something like you can call it a factory, and then you have methodologies, technologies. And this factory generates the output. So in the museum area, for example, you have as input an object. You have people that as curators. The process is the object entry. The methodology might be spectrum. The technology is a computer system. And there's an output. You have a database record describing this object. Or you can also have a 3D visualization of this object and anything else. So I hope this explains a little bit the situation. And if we look into detail, then we have a so-called notation. So business process model is using symbols to describe these processes, and this is called the notation. And here we're coming to the standard business process model and notation. And there's a lot of other notations for decision making and so on, but BPMN is that thing which is of interest for us. And I have put on this slide the core set of BPMN elements. You have here flow objects. You have in flow, in this category, you have events. Events is, for example, an email is arriving. For example, an activity can be make a record of an object. A gateway could be a decision. Is this object in good condition to be entered in the collection or not, for example? Then you have a connecting object. You have a sequence flow. You have different steps which are executed in consecutive orders. So first you have to inspect the objects, and then you can make a documentation, and not the other way. That is a sequence flow. That is within a flow, within processes and procedures you are doing, you are connecting these different steps. In the other overheads, I have shown you step 3 to 5, and these steps are executed in consecutive orders. And this sequence is identified by a sequence flow. So you have a communication with a depositor. For example, the depositor communicates with the museum curator. Then you have a message flow that is here. And then you have probably some artifacts connected to a step. So if a step, in a step it's included the documentation of the object, registration of the object, you are generating a document for the registrar. And then you have an artifact. This artifact is a text annotation, for example. This is associated with an artifact. Then the next are the swim lanes. I don't know who has invented this term, but it's coming from the sport side. And swim lanes represents an organization. I've mentioned before that it's very important to have the role of an actor. So it's important if you have a curator doing scientific documentation, you have a registrar who is only doing administrative things, for example, or you have a collection manager who is doing some other task. So you have different roles, and the different roles are connected with a swim lane. So you mean all processes in one swim lane is connected to a role. So all activities of the curator are written in this rectangle. In the previous overhead, you have seen the human operations and the computer operations. So we have one swim lane for the human being, for the curator, and one swim lane for the technical environment. And if you're looking in the museum, you have administrator, you have restaurators, you have many other people which are doing specific tasks and which are dedicated to a specific pool. That is a basic element. It's not very much, but it goes far beyond to flowcharts, if you know this, if you have heard about this already. So that's basic things. We have steps, we have decision points, and we have sequences. That's very important. And one example of this visualization is a flowchart. That's a little bit simpler. It's a type of a diagram that represents an algorithm, workflow, or process showing the steps as boxes of various kinds and so on. And I'm wondering, when I was a young student many, many years ago, I used this already. And after 50, 60 years, it's still used. So something is valid and stays forever, probably. And here you have, as a reminder, flowchart symbols. So you still can use it. So that's a very simple way, but you don't have roles and you don't have swim lanes with it. And you have these symbols and symbols. You have the ISO standard. You can buy it from ISO or look somewhere in the internet. You have the symbols. A circle is something like a connector. In previous time, we have used paper, and then one paper sheet in format in A4 was not enough. You need different pieces of paper, and then to connect these papers, you need a connector that is a circle. Then you have a starting point of an algorithm. It starts with this symbol. Then you have a step. That is what we have already seen. That is a rectangle. Then we have the flow. Then we have a decision point, diamond. I have a mathematical education, and this decision comes from the numerics. You wonder that the process comes to this corner here, and then we have three ways. If you decide for true and false, you only need two exits, but here we have three exit Y because it comes from the numerics, and a number can be negative, positive, or zero. For that reason, this diamond has three corners. And then you have part of a paper output. That is something what we are going to produce. And here you have on the right side how this is used. You start here, you make a decision, and so on. Yes, it is quite simple. You see, you have a question. You have, is it raining? Yes. Drive car. No. Ride cycle. And then end. I have no car and I have no cycle, so I stay at home. Okay, and we have now the spectrum standard. This link is still working, points you to the actual version 5 of standard. But as I told you, the basic concept is still valid since many years. And I'm using still version 3 because I have controlled this, I have checked this, and this is an excellent framework. Spectrum is a guidance to 21 collection management procedures, or 22, helping to manage all activities associated with the life cycle of collection objects. It was developed by the Spectrum community, the organization behind this collection trust now, and is widely used nationally and internationally. But these are only guidelines. It is not a computerized system. It's only guidelines. It has a status of a standing operating procedure, even a little bit before this. And I think this is still valid to 95%. I have put a sequence number to these procedures, and you have in bold letters the main procedures in a museum. I think this is used for accreditation in the UK to become a museum. So you have to demonstrate these 8 procedures are available in your museum. You have object entry, loans in, acquisition, location and movement control, cataloging, object exchange, loans out, retrospective documentation. And I'm using for my presentations and for my courses the object delivery process. So I named this as process object delivery. It's not part of Spectrum, but we are using steps in the Spectrum environment. And here we have the object entry procedure. So if you look into object entry procedure, you find different steps. Step 3, prepare for the arrival of an object. Step 4, make record of the object. Check the condition, make a record. 6, give a copy of the record information and send a copy of the receipt to the depositor. So I'm only looking into some specific steps which I'm using in my presentation. You could also add your own procedures to it. So, but spectrum covers a wide range. What is not here, you know, my favorite work at the moment is artificial intelligence, is additive manufacturing, digital twins, and all these things. So probably this comes into the museum's topic some way. For example, a digital twin is a very important thing. And probably in 5 to 10 years, we have other processes, how we are generating a 3D object and so on. So we can put your own things. It depends on the mission statement of your, on the nature of your collection. If you're describing these different steps, we have here 4 steps. Then one is prepare for the arrival of an object. So the depositor sends a notification to the museum. So it is for our computerized process, which is at the end the outcome of the business process modeling. Then that is a starting point of our business process. Then if the notification is sent to the museums, not the object direct, but only a small verbal description of the object, the curator consults a checklist. For example, if I'm collecting birds in a natural history museum and the depositor is giving me a car that does not really fit into my collection if I'm not collecting cars. So I have a checklist. In the checklist are the different policies of the museum, what is the collection mission, and so on. And after this consultation of a checklist, the museum informs the depositor whether the object is acceptable for the museum or not. And then the museum could send a rejection letter to the depositor. If it's acceptable, then the museum makes a record of the object, and the depositor is asked to send the object or bring the objects to the museum. And then we have to define the arrival of the object, transportation issues, and so on. And the museum curator makes the first record for the database. Then we have these formal things: give a copy of recorded information to the depositor, send a copy of the receipts. This can be one thing. And this I already have explained to some end. And then when the depositor, when the museum gets the object and the depositor gets a receipt of the object, then this process, I called it, sorry, I have to look, acquisition of an object, it's delivery. It was a delivery project. Yes, that was a model, the object delivery. And this is at the end when this receipt has to be distributed to the depositor. And now we can model this in the old-fashioned workflow diagram. I think that this might be, I think you're aware of this. And then we have a starting point. Then we have an activity. Depositor sends a notification to the museums. The curator consults a checklist. Now we have an artifact that is C01. That means I have a checklist where I have to browse this checklist and say, okay, this is okay, this is okay, so the condition is okay, it's in line with my correct with a policy and so on. So it is a checklist. And then the museum informs the depositor whether the object is acceptable for the museum or not. Now we have here the connector. The workflow continues here with 1. Then we have the decision. We have here no numeric, and we have here a logical decision, no, yes. So the decision is the object accepted? It can be yes or no. If it's not accepted by the museums, then we have to produce a rejection letter and send it to the depositor. And then the process is at its end. If yes, then the depositor informs the museum about the arrival of an object. Curator makes a record of the object. You have here in numbers the different steps, which I'm using later on and have already used. And then to make a record, you need a user interface, and we call it mask. And I have already, I think, some hundred masks, probably not some hundred, but a lot of masks generated out of the Spectrum standard, which you can implement on an app or on a program, a standard PC program, and so on. Then you generate a receipt, send a copy to the depository, and ask for the copy to be signed. Okay, and returned. So museum needs a copy. Then give a copy, 6 is give a copy to the recorded information repository, and then send it and ask to get it back. And then if the receipt is got back to the museums, then we have the end of the workflow. We could have here another cycle where we could write end. That is the end of the delivery process. You see, that is a process. And if you look into the Spectrum standard, you have procedures. So here you have a self-contained thing which can be implemented as a computer program, and the guidelines between are laid down in the procedures, in the Spectrum procedures, or in the CIDOC procedures or something else. And now it's getting more and more complicated, probably. We have already tools supporting this, and these are not very new tools. This is an editor for generating BPMN diagrams. And it's developed by a company called Signavio. Signavio is a spin-off of Hasso Plattner's enterprises. Hasso Plattner is a founder of SAP. I think SAP is known to you. And one activity out of his institution is Signavio. And you have already, probably if you remember his name, if you Google Signavio, you find a free version, a trial version valid for 30 days, where you can use this editor already. If you have time, probably I can show it to you. And this is an outline of this editor. And here you have now 3 lanes, 3 swim lanes. I have a depositor sending and offering an object to the museum. I have the museum, and then I have a technical lane that is a computer system, it's a computer program. So we have human actors and we have artificial actors. We have, yes, that are technical actors. And the starting point is here. And we have a comment to this starting point. Depositor has a new object. And this initiates the steps of the depositor. The depositor prepares an object and depositor information and send it to the museum. So write an email to the museum, for example, introduces himself if necessary, describes the object, and offers this to the museum. Now we have a communication link between depositor and between museum. I didn't structure more in detail the museum, but this could be a sublane, for example, as we call it a swim lane. We have pools. Here we have pools. And if we are dividing these pools into swim lanes, that is coming from the sports. So we have, for example, 8 swim lanes at Olympic Games or somewhere else. And here we are putting together it in one pool. And in the museum, there's one person, for example, we could have a swim lane for a curator or for the registrar, receives and manages information from the depositor. You see now the depositor is waiting. It's not doing anything. And now the museum is working. And the next step is we have to consult the checklist. So the computer, the curator, for example, looks into an Excel sheet or into a database or in a lookup table or something else, and looking at the checklist. The checklist connected with the acquisition of an object. You have different policies to recognize, and this is also laid down in Spectrum if you look in detail. So this can be implemented by a computer program which pops up on your screen, and then you can browse some terms, and you can cross it, okay, this is okay, this is okay, and so on. I will give you an example later on. Once you have consulted the checklist, then you make your decision, and you prepare this information and send it to the depositor. So the information which you are preparing is more or less acceptance notification. So we are communicating now back to the depositor, and we send him a message, him or her a message, an email, and in this message we have the decision, the object is accepted or not accepted. If it is not accepted, then the whole process terminates. So we have no further activities in this process. The object delivery stops with a non-delivery in this case. So in both lines, so the depositor finishes his job, forgets about this, and the job is also finished now, and the task for the museum. So that is the end of this process. But if it's accepted, then we go ahead. Then the depositor prepares some information when it will be delivered, what are the delivery methods and so on, and sends this message to the museum. You see, the museum has also not terminated, has it accepted, and this waits now for this message. This message arrives now at the museum, and the museum make now a first record. That is an entry in the registrations book, or in the registration that is done by a registrar. So if you are subdividing this pool, we could make here a swim lane for a registrar. And then we can dedicate this process, task, this step, to a registrar. So this is step number 4. And then we are entering this data. In former time, it was in a book, in a registrar book. Now it's now it's done by a computer. Probably you can apply artificial intelligence to anything else to get more information about these objects. This probably will come in the next future. And then we're entering data into this database. And you have to consider the database as an empty container, which is now getting more and more information about an object. Now, the first part of information was already done here, but this could be deleted if the object is not accepted. But if it's accepted, some information from here probably is already copied here. And we have a first information about the object. And then we have probably some semantic relations from the object or something else. Here, as a working group of CIDOC come in place, CIM, LIDO, and so on, how structuring data, and so forth. So we have made a record, and then we are generating this receipt to the depositor, and we're handing over this receipt to the depositor. And since this part is at the end, and we have it now terminated, this whole delivery process by this ending symbol, and this also ends this this process in the museum. So it's not only the object entry, it's a little bit more what you see here. You could have other processes, for example, condition checking. You could already start, initiate a restoration process and something else. So here I have given you a short explanation of these different processes. And I brought this course some years ago, and it was part of a 4A4 course in the United States. And this was one of the examples to describe this process in a specific museum, to formalize this. That's a very interesting thing if you have had 3 or 4 students at these times. So if each student is describing his or her process in his or her museum, then you can compare this. And then you compare this to standards. This goes into the quality control in the future, control of procedures. So we are talking here about activities and not about data. I hope this is clear to you. And if you Google to Signavio, you can register yourself for a 3-day free version, and you can do it yourself. It's quite nice. This is now the group work I have done when I did this by face-to-face. I introduced yesterday to some extent my this working group, and because of these virtual seminars now and webinars, I'm planning now, I'm still evangelizing this methodology. I'm planning for the next year, probably every 2 months, to make an online course here and to, if at least 3 interested creators are available, to make an interactive course out of this, and then we can do these examples. So the time is 20 minutes. You can do it after my presentation. Now the second part of my presentation is now dedicated to data. So this was, I mentioned already before, we have a lot of activities in data structuring. Probably you are aware of XML. It dates back to the CALS initiative, you know, in the XML is based on HTML. HTML was developed in the CALS, that was in military activities in the 70s last century. And the basic behind was to computerize the maintenance book for the armies. So this was a preparation for the end of the Cold War already. We are putting different mobile unities of the army to different parts in the world. And then you have to put your equipment with you, and then you need maintenance books. And out of this military activity, XML was invented, because HTML was not really easy to manage. So XML was a simple thing. Markup language, it was extensive markup language. HTML was called structured generalized markup language, for example. And here you see a description of the information object which have been referred to, or still are referred to, by spectrum. So we have this organized in information groups, for example. We have here, for example, the identification element. That is from the schema, and the information element has sub-elements. Here you have a verbal description of the XML, and here you have a graphical description of the XML. And you have here the identification element. Then you have an administrator name. You have a brief description for identifying this object. You have a spectrum unit name. You have a spectrum decision description, and so on. This is quite very, very interesting, because if you use this for setting up your own collection management system, then you can use this already as an input for your computerized processes. And I have by myself developed a concept of a collection management system, which is quite popular in Germany. It was Indus. And this follows to some extent to this, or has been followed as long as I was involved. Then you have here, for example, the object identification information. And part of this is identification of an object. And then you have here data fields. So we have a group of objects, and this group of objects is divided into data fields. So that is a basic element of data. Probably you know XML is an hierarchical structure of an object, and this follows exactly. And so XML is quite usable for this application. And that's what at this time we did in this project. We looked into the interrelation between information groups and between processes. For example, we have here the object identification information. Okay, that we have seen already. And you have here groups which belong to common procedural units. What is a common procedural unit? So, for example, an address of a person. So we have different roles. We have persons, we have objects, and so on. And with a person, you have an address. And this is it's a common thing. It's not dedicated to an object or something. We have acquisition information, audit information, and so on. That's very comprehensive. Probably what's lacking here is a future where we have more and more digital objects. This was at the time not popular. So that's probably confusing to you. I have made a copy of the Spectrum 3 at this time, and that was an outline. A unit of information is an object number, an other number, brief description, and so on. These are information units. A number could be, for example, an inventory number of another museum, if you get this as a gift or something. Okay, now I have to remind you on the diagram we have seen some minutes before. And in this diagram, which we analyzed what we have got from the depositor, and we made a record out of this information from the depositor. And we're using a data screen. And this data screen is using some data elements. So this is this part here. We're using a data screen, M01, in step 4. Yes, and here you see part of dozens of Excel sheets we have, which are still available. And if this group is getting more active, I could provide to this group all this information, guidelines. There's a lot of paper already. But as I told you before, it was still too early. Probably now it's also too early. But this information is not getting old. So we have here the different information groups, data information or data fields, information units. So information units are grouped in information groups. And here are the units you have in a data entry screen. So data entry screen is identified here by M01, mask 1. And here we have address information, we have date information, we have insurance information, if available, we have object collection information, we have object identification information, we have organization information, people information, person information, valuation information. For example, people information can be connected with addresses or something else. So we have here the data field, and this is already addressed by Spectrum. And that is quite interesting. So you have an interrelation between data and processes. So that's very, very important. So this is implicit knowledge you have in collection management system, but here you have it very nice elaborated. And you see, so here we go up to M30 screens. And you can, for example, automatically generate out of this data and data entry screen. So there's no problem. And we have also some other information like is this thesaurus controlled, is this vocabulary behind or something else. Then we have checklist, for example, and other things. So mask 1 uses object identification, that is the object group, and this is identified by this number. So it goes too much into technical detail. So this tool, I hope I can make it transparent to you. It's very important if you are setting up a system. It's very important if you have to decide what system you're using, so you can check a cataloging system against this information, against these roles and information. So information groups is the next level, is object entry, object identification information, valuation, insurance collection, data information, organization information, people information, address information, and I would add here now digital information. That is where you have 3D reconstruction, you have audio, smelling probably, you can also digitize if you want, and other things. So this is things to come. And now we have here another table that is a connection to a relational database system here. We have units information, and these are implemented in a relational table, and then you have columns in this table. So we here go already to the implementation. And my working group is called Museum process implementation. So we are targeting into the implementation of a standard the system. And I did this not only theoretically. I had a small project where I started to implement this. What you see here is a data entry screen used by, yes, the tool was quite an interesting tool. You had the possibility to generate a first outline of the screens here as a database. And then by dragging and dropping, you could enter this layout of the here. For example, you have this object number, number type, and so on. And you have vocabularies, and you then some vocabularies are popping up, and so on. And that is, I called it non-programmer view of a developing tool. And if you're a programmer, you can switch to this here, and then you get a JavaScript code. So the programmer can then implement the system using JavaScript, for example. This is already 10 or 12 years old, so it's not very new, but it's still state of the art. Probably this editor is still not used. Or not available, sorry. And I elaborated a little bit more the data entry screen. So similar things I did before the break with the processes I'm doing now with information. We have here information units. This is laid down in the XML, Spectrum XML, for example. I think this is not long available, but to 95% it's still valid. And then you have, I think you can get it. And then you have here the information units and the information groups. The information group here is, for example, object entry. No, here we have it. Object collection, address, date, and so on. That is a proposal for a layout of a data entry screen. That means you click on the different information groups, and then the information units are popping up. So you have the same procedure for all different information units you have in the system. That's quite interesting. So you are not getting an overloaded screen. You get first a selection of the information groups, and then you click the groups you want to enter, and then you get the data fields, like you have it here. And here you have, you can connect now the guidelines from Spectrum, make a record of the object, and so on. So you have this information connected with a step, with a part of the procedures, of the standard operating procedures I have started to explain at the beginning. And then you have all the rules. So it means you have already the guidelines and the whole rules connected with the system. Once you have elaborated this, and this we have already. Now we're going back to this diagram. We had here this part, receive, that is the result. No, sorry, that is the next now checklist. We had here the data entry screens, and now I spoke about checklist. That means if an object is offered, you can consult the checklist. And now that is this part here, and we execute a checklist in the computer. And this could be a pop-up table. You will see it in the next. This is a checklist, for example. That was an XML and Xforms systems. Xforms now is out of discussion. But this was a server where you have been able to put an XML to it. And this generated an outline, a screen. And this was a checklist here. So I mean, clarifying any specific terms and conditions, briefing relevant persons, having a storage location available, and so on. So it has different checkpoints, which you have now to check. You can say, okay, this is fulfilled, this is not fulfilled. And some responsible person for the acquisition of a project, of an object, has to check this. There's something which I will, yesterday mentioned in my short introduction, that was control. That means everything what I see here is stored in a computer program, in a database. That means you have to do this, and this is stored. And once you have not done this, then it's a fault of the responsible person. And it's over 10 years ago when I spoke to a museum director in Europe with this. He said, I will never use your system because I do not want to control my people. So that is a misunderstanding of this. We are doing control because for quality reasons, not for punishing people, So it's only for controlling the quality of a system and the service. So that's one remark. Yes, and I'm really close to the end now, really at the end. I hope some of you are still awake, and I think we can accept some questions in the chat if you want. So thank you very much.